Alright, welcome to this explainer. Today, we're taking this foundational CLI commands we learned previously, and we're going to combine them to handle a real nightmare scenario, a production disk space critical incident. You know, before you blindly start deleting massive logs just to free up space, you absolutely must scan them quickly for root cause errors, so you don't lose that vital forensic data. So, we're going to automate that exact soul-crushing task today.
Well, let's dive into an extreme contrast. Think about the reality for a lot of engineers out there. Staring at terminal logs, frantically searching file by file for 4 excruciating minutes while the entire system is melting down. Now compare that to running the exact same diagnostic workflow as a script. It diagnoses the issue in exactly 2 seconds. 2 seconds every single time. And honestly, you don't even have to touch it.
Here is our roadmap for today. We're going to build this step by step, covering script safety, variables, conditionals, loops, functions, and finally, pipeline assembly. Starting off with Section 1, Script Safety. This is the essential foundation of any good script.
So the crucial point here is setting up your safety net. By adding set-e uo pipefail right at the top of your file, you're enforcing some very strict rules. Without this, a failing script will just quietly keep going and do the wrong thing instead of failing loudly. And let me tell you, a script that silently continues after, say, a database connection fails, that is a DevOps nightmare. We want our scripts to fail loudly and immediately.
Moving right along to Section 2, Variables. This is how we store and reuse our data.
Now, there are 3 main ways you're going to define variables in the real world. You've got your standard string assignments and command substitutions where you capture output from things like the date command. But that default fallback syntax, that is absolutely vital. You're going to use this constantly when pulling secrets or configurations in GitHub Actions workflows. It essentially tells the script, hey, use this environment variable, but if it's missing, just use this default value instead.
Before we go any further, let's do a quick troubleshooting segment for the #1 beginner trap I see literally all the time. Do not put spaces around the equal sign. If you type name space equals space DevOps, Bash doesn't think you're assigning a variable at all. It actually thinks name is a totally separate command you're trying to run, and it's going to fail. So keep it tight. No spaces around the equal sign. Always quote your paths. And hey, remember, if your script throws a permission denied error, you probably just forgot to run chmod +x to make it executable.
All right, Section 3, Conditionals. Let's add some logic to our script.
To make our log scanner truly smart, it can't just blindly run commands. We use conditional flags to verify our log directories and files actually exist and have data in them before we do something like run grep. If you try to read a log file that isn't there, your script is going to throw an error. So using -f checks if the file is present, and -s checks if it actually has content inside it.
Now, when you're writing these conditionals out, make sure to always use double brackets instead of single brackets. They are a Bash-specific, safer, and much more robust syntax. It prevents those weird, hard-to-find word-splitting bugs in your logic, and it even lets you use regular expressions. Basically, if you control the environment, always go with double brackets.
Okay, what's really interesting here is that or true statement at the very end. Remember that strict safety net we set up earlier? Well, because the grep command natively returns a failure code when it finds 0 matches, our super strict script would completely crash if a log file was perfectly clean, which is obviously not what we want. By appending or true, we catch that failure. It essentially says, if grep doesn't find an error, don't panic, just gracefully accept it and move on.
Section 4 is loops. This is how we process data at scale.
Checking one log manually is fine, sure. But if we need to check a whole server cluster during an incident, we absolutely have to scale up using loops. There are 3 main ones to master. The for loop with a glob is amazing for auto-detecting every single log file in a folder. This is magic because if a totally new service is added to your server tomorrow, your script adapts and scans its logs with 0 code changes. You've also got the while read loop for safely parsing files line by line, and your classic C-style loop for counting.
Inside those loops, you control the actual flow of traffic with break and continue. And when you combine them with that counter loop we just talked about, it lets you build the classic attempt, wait, retry pattern. This is quite literally the backbone of robust deployment scripts. If a database isn't ready to connect, your loop catches the failure, waits 2 seconds, and just continues to the next attempt.
Next up is Section 5, Functions. Time to build reusable code blocks.
Once your script crosses, say, about 30 lines, you've got to break it down into chunks. When you build a function, you name it, run your logic, and output the result. But here is the absolute most important part. You must declare your variables as local. If you forget to use that local keyword inside your function, those variables become global. They will overwrite variables with the exact same name in the rest of your script, causing massive, impossible-to-trace bugs.
You also need to remember that bash functions are a bit quirky compared to languages like Python or JavaScript. First off, they have to be defined at the very top of your file. Second, they fundamentally return status codes, just numbers representing success or failure. So if you actually need string data back from a function, like a log parsing result, you have to use echo to print it out and then capture that output when you call the function.
And finally, Section 6, Pipeline Assembly. Let's put our final script together.
We've got all of our building blocks now: variables, conditionals, loops, and functions. By snapping these highly focused elements together, we've created a complete log scanner script, check_errors.sh. It dynamically finds every single service loop by loop, counts the errors using grep, evaluates them, and safely prints out a beautifully formatted health report. We literally just took 4 minutes of pure panic during an incident and reduced it to a calm 2-second execution.
And because we use that brilliant variable default pattern right at the top of our script, your brand new tool is fully configurable directly from the command line without ever editing the raw code. If you want the error threshold to be 0 instead of 5, you just pass that in. This makes it incredibly easy to trigger dynamically in a CI/CD pipeline. Like in GitHub Actions, you just add a run step executing ./check_errors.sh, inject your variables, and you're done.
Finally, we have to talk about the number 0. This is the universal Linux exit code for success. By controlling your script's exit codes, returning a 0 when logs are clean, and maybe a 1 or 2 when critical errors pop up, you dictate exactly how GitHub Actions or a Kubernetes health check responds to your automation. Those exit codes are exactly how your script talks to the outside world.
As we wrap up this explainer, I really want you to take a hard look at your own daily workflows. What repetitive, soul-crushing task is draining your time that you could easily just script away? As a practice exercise this week, I highly recommend using the loops and variables we learned today to write a quick log rotation script, something that finds large files and automatically zips them up. Because now that you know how to scan for errors, rotating those logs is how you permanently resolve that disk space incident. Automate the tedious stuff and get back to building. Thanks for watching, and I'll catch you in the next one.